Introduction. Before starting with the concept of variation, let us revise what we have learnt in our earlier class about ratio and proportion. Ratio. When we compare two quantities by division, that is, by dividing one with the other, it is called as ratio. Proportion. If after comparison two ratios are equal, they are said to form a proportion. That means four numbers P, Q, R and S are in proportion if P is to Q is same as R is to S, that is, P is to Q is equal to R is to S, or P upon Q is equal to R upon S. The product of their means is equal to the product of the extremes. Direct variation. Two quantities are said to be in direct variation if the increase or decrease in one quantity leads to the increase or decrease in the other quantity in such a way that their ratio always remains constant. We say that one variable varies directly as the other. Constant of variation. The symbol used to denote variation is proportional. When A and B vary directly with each other, we can express this fact in mathematical language as A is directly proportional to B. If K is the constant of variation, then A upon B is equal to K, or A is equal to KB. Example 1. Given x is proportionate to y, and when x is equal to 15, y is equal to 3, find 1. Y when x is equals to 35, and second, x when y is equal to 4. Solution. If x is proportional to y means x upon y is equal to k, where k is the constant of variation, this implies that x is equal to ky. When x is equal to 15 and y is equal to 3, this means 15 is equal to k3 or k is equal to 5. 1. Using this value of k, we have x is equal to 5y. So when x is equal to 35, it implies 35 is equal to 5y or y is equal to 7. 2. When y is equal to 4, x is equal to ky. This implies x is equal to 5 into 4 or x is equal to 20. Relation between direct variation and proportion. Example 1. Rashmi has a road map with a scale of 1 centimeter representing 18 kilometers. She drives on a road for 72 kilometers. What would be her distance covered in the map? Solution. Distance on map and actual distance are directly proportional. Distance on map, actual distance 1 centimeter, 18 kilometer. X centimeter, 72 kilometers. This implies 1 is to x is equal to 18 is to 72, or 1 is to x is equal to 1 is to 4, or x is equal to 4 centimeters. Example 2. A laborer earns Rs 141.75 in 26 weeks. How much money will he earn in an year? Solution. Since earning increases or decreases in proportion to the number of weeks, therefore the two quantities vary directly. We know that income 1 is to income 2 is equal to number of weeks 1 is to number of weeks 2. So, 141.75 is to x is equal to 26 is to 52, as 1 year is equal to 52 weeks. This implies that 141.75 into 52 is equal to x into 26, or x is equal to 141.75 into 52 upon 26 is equal to 141.75 into 2, so x is equal to rupees 283.50. Thus, he earns rupees 283.50 in a year. Example 3. A machine produces 180 tools in 6 hours. How many tools will it produce in 9 hours? Solution. Let x be the number of tools and y be the number of hours. From the question, y is proportionate to x, or y is equal to kx, where k is the constant of variation. When number of tools is 180 and number of hours is 6, then 6 is equal to k 180, or k is equal to 6 upon 180 is equal to 1 upon 30. Thus, y is equal to 1 upon 30 into x. We find the value of x when y is equal to 9 hours. This implies that 9 is equal to 1 upon 30 into x, or x is equal to 270. Thus, number of tools is 270. Inverse variation. When one quantity increases, the other decreases proportionately, and when one quantity decreases, the other increases proportionately. This kind of variation between two quantities is known as inverse variation. We say that the two quantities vary inversely. Constant of variation. This product is the constant of variation for the inverse variation. That's why when x and y vary inversely, we write x is proportional to 1 upon y, or x is equal to k upon y. Then xy is equal to k is equal to constant, and k is positive. Inverse variation and proportion. If x1 and x2 are two different values of x, and y1 and y2 be the corresponding values of y, then x1 y1 is equal to x2 y2. This implies x1 upon x2 is equal to y2 upon y1. This result is useful in solving inverse variation problems. Also, x1 upon x2 is equal to y2 upon y1 implies that x1 is to x2 is equal to y2 is to y1, or x1, x2, y2 and y1 are in proportion. Example 1. Given that x varies inversely as y, and when x is equal to 5, y is equal to 50. Find 1. Y when x is equal to 2, and 2. X when y is equal to 10. Solution. Since x and y vary inversely, this implies x is proportional to 1 upon y, or x is equal to k upon y, or xy is equal to k, where k is a constant of variation. This implies when x is equal to 5, y is equal to 50, or 5 into 50 is equal to k, or k is equal to 250. Thus, xy is equal to 250. 1. When x is equal to 2, then 2y is equal to 250, or y is equal to 250 upon 2 is equal to 125. 2. When y is equal to 10, then x into 10 is equal to 250, or x is equal to 250 upon 10 is equal to 25. Thus, for x is equal to 2, y is equal to 125, and for y is equal to 10, x is equal to 25. Example 2. A car takes 2 hours to reach a destination by traveling at the speed of 60 km per hour. How long will it take when the car travels at the speed of 80 km per hour? Solution. Speed and time taken are inversely proportional. Since more the speed, less is the time taken. Speed, time taken. 60 km per hour, 2 hours. 80 km per hour, x. 60 upon 80 is equal to x upon 2, or 60 into 2 upon 80 is equal to x. So x is equal to 1.5 hours. Example 3. A farmer has enough food to feed 20 animals in his cattle for 6 days. How long would the food last if there were 10 more animals in his cattle? NCERT. Solution. The more the number of animals, food will last for less number of days. So number of animals and number of days are inversely proportional. Number of animals 20, number of days 6. Number of animals 30, number of days x. So 20 upon 30 is equal to x upon 6. This implies 20 into 6 upon 30 is equal to x. That is, x is equal to 4 days.